Hello class, and welcome to this week's video lecture. So last week we discussed static electricity, which is basically when electrons build up on an object and create an imbalance of charges. So this week we are discussing current electricity and electric circuits. So I want you to take a minute to think about your day so far. Think about how many times you think you have used something that required electricity, from the alarm clock that woke you up this morning to turning on your lights to get ready for the day, all the way up until now when you are using a computer or a cell phone to watch this video and take your notes. So just write an estimate on how many times you think today you've used something that required electricity, and write down the first 10 things that you can think of that you have used today requiring electricity. So anytime we talk about electricity, we have to go back. We have to go way back to some of our earliest standards of the year when we discussed matter and the structure of matter. So matter is everything around us that has mass and takes up space. Matter is made up of tiny particles called atoms, and every atom is made up of even smaller particles called neutrons, electrons, and protons. So if we remember from our early discussions about atomic structure, protons have a positive charge, neutrons have a neutral charge, and both of those are trapped inside the nucleus of every atom, whereas electrons, which have a negative charge, orbit around the nucleus of the atom in energy shells or energy levels. And while protons and neutrons are held together in place in the nucleus of the atom by the strong force and really can't go anywhere, electrons, particularly the electrons in the outermost energy levels, or the valence electrons, are able to move around from one atom to another. So when we did our chemistry unit, we saw how electrons moving from one atom to another contributed to different phenomena related to chemical reactions. But the other phenomenon that we see related to electron movement is electricity. So all electricity is caused by the movement of negative charges. So whenever you think about electricity, think about electrons. So when we are able to make electrons move along wires, we call it electric current. So the kind of electricity that we normally deal with on a day-to-day basis is the electricity of electrons flowing around a circuit. And this is the way that we control the flow of electricity in our homes, for example. We create circuits. And an electric circuit is just a closed path along which electrons are able to flow. So every simple circuit has to have three basic parts. First of all, we have to have some kind of power source, for example, a battery. We have to have wires along which the electrons are able to move, and we have to have some kind of load, some kind of work being accomplished by this flow of electrons. And a lot of times in early experiments and diagrams, this is represented by a bulb, but it doesn't have to be a light bulb. It could be a buzzer, it could be a fan that you were able to turn on. It can be just about any kind of work that we are able to make happen by the flow of electricity. So let's look at each of these parts. And as we look at each of these parts, I want you to write down the different things that you see on the presentation into your notes in the appropriate spot. So the first part of any simple circuit is the power source, the battery. So batteries are called power sources because they are the thing that provides the push that starts and keeps the electrons flowing through the circuit. So every battery has two parts. It has a positive end and it has a negative end. The negative end of the battery is the part that gives up the electrons. It's the part that pushes them out and starts the flow through the circuit. And as the electrons move out of the negative end of the battery, they are attracted back to the positive side of the battery. So the positive side of the battery is the part that takes the electrons back in. And this makes perfect sense if we think back on our three basic laws of electrical charges. Like charges repel, opposite charges attract, and both positives and negatives are attracted to a neutral. So when we remember that electricity is caused by the flow of negative electrons, these negative electrons are going to be repelled or pushed away by the negative end of the battery, and they are going to be attracted back to the positive side of the battery, because likes repel and opposites attract. The second part of every simple electric circuit is the wires. And wires are what the electrons flow through. So most wires have two parts. They have a metal part in the center, and they have a plastic part or rubber part that is wrapped around the metal part. But why? Well, wires in a circuit are usually made out of copper. That's the most common metal to put in circuits. Electrons move very easily from atom to atom in metals because metals are what we call conductors. They allow the flow of electrons. But we want to coat these metal wires with rubber or plastic because the rubber or the plastic is an insulator. And if we remember, insulators do not allow the flow of electrons. So that rubber or plastic coating allows us to safely touch the wires without having to feel the electric charge from the electrons moving through the wires inside. So the third part of every simple electric circuit is the load. And again, it doesn't have to be a bulb. It can be a buzzer. It can be a fan. But we are going to talk about bulbs. So bulbs, particularly traditional bulbs, have a filament inside of them. And if you ever look inside of an old cheap glass bulb, you will be able to see the filament wire inside. It's very thin, so electrons actually have a difficult time passing through this wire. Even though it's metal and it's a good conductor, it's very thin, so the electrons have to work really hard to get through. And when the electrons do pass through, they heat that filament up so much that it starts to glow. And this is what causes the bulb to light up. Now, another part of a lot of circuits is a switch. Now, simple circuits don't require a switch, but switches are helpful because they allow us to open and close the circuit. When you have a closed circuit, the electrical circuit is complete and electrons can flow through the entire circuit without any kind of interruption. But if you flip the switch in the opposite direction, you can create a gap in the circuit. You can open the circuit. And when you open the circuit and create that gap, the pathway is no longer complete and the electrons aren't able to flow. So if you think about a light switch in your house, when we flip the switch up, the circuit is open. When we flip the switch down, the circuit is closed. So we can turn the lights in our house off and on through that light switch by simply opening and closing the circuits. So there are two main types of circuits. You have series circuits and you have parallel circuits. And this is the basic look of a series and parallel circuit. So if you take a look at them for a minute, think about it, look in your notes, and write down what you see initially as the difference between these two types of circuits. And just pause the video if you need a little more time to write down your observations about what you see as the difference between these two types of circuits. So, in a series circuit, we see only one path for the current to flow. So if we remember from our battery, electrons flow out of the negative side of the battery because the negative charge is repelled by the negative side of the battery. They flow outward into the first bulb, straight through the first bulb, into the second bulb, out of the second bulb, and then they are attracted back into the positive side of the battery because the negative electrons get attracted back to the positive end of the battery. So that is your basic series circuit, a single pathway from the negative end of the power source back to the positive end of the power source. In a parallel circuit, on the other hand, you can create more than one path for the current to follow. So if we go back up to our battery, and we know that the negative electrons are going to be repelled by the negative side of the battery. So they're coming out of the negative side of the battery, going down to the first bulb, and then they can go through the first bulb back to the positive end of the battery, or they can be pushed out of the negative side of the battery down to here, straight on to the second bulb, then up through the second bulb, through the first, and back to the positive side of the battery. So you have a couple of possible pathways for the electrons to follow. So which type of circuit do you think we put in our homes? So think about it for a minute. What would happen in a series circuit here with only one pathway to follow if this first bulb were to burn out? Well, the electrons would go through the negative side of the battery into the first bulb and find it burnt out. And that's where the flow of electrons would stop. On the other hand, in a parallel circuit, we have electrons coming out of the negative side of the battery, and some of them are going to go straight into this first bulb, whereas some of them are going to go on into the second bulb. So if our first bulb burns out, some of the electrons are going to find a dead end. But some of them are going to go through the alternate pathway, go through the second bulb, which is still working, and follow that alternate pathway back to the positive side of the battery. So, thinking about it that way, what type of circuits do you think your home has? Well, most homes are made up of parallel circuits, and each outlet is connected to a circuit box. So if too much current passes through an outlet, it can overheat. But in order to protect your house, the circuit box has a safety feature called a circuit breaker. So if one of your outlets overheats, it could cause one circuit to overheat and melt that circuit so it opens up. And once you have an open circuit, you have a gap, and that pathway is closed. That pathway has a dead end now and won't work. But because your house uses parallel circuits, just because the circuit for one room is broken, the current can still pass to circuits in other rooms. So if you have a toaster in your kitchen that overheats, it can blow out the outlet that that toaster is plugged into. And if you go to the circuit breaker in your house, you might actually cause the circuit breaker for your kitchen to overheat enough that it flips to the off position. So until you fix that circuit, your entire kitchen might be cut off. Your microwave might not work, your kitchen light might not work, your electric range might not work, even your refrigerator might shut down temporarily. But the shutdown is localized to your kitchen. Because your house runs on parallel circuits, you have several alternate pathways. Every room in your house is connected to a different pathway. So even once your toaster overheats and this kitchen circuit is flipped off, your living room lights will still work. Your bedroom lights, your bedroom ceiling fan are still going to work, and the lights in your bathroom will still be okay, because parallel circuits in different rooms are connected to different fuses or circuit.